Hello friends, welcome to Vidyalankar. Today we are going to discuss the very basic topic on digital electronics. This is logic gates and Boolean algebra. This topic is useful for second year diploma students under the subject DTE or digital techniques. Now all of you know how analog electronic works. This is digital electronic. So basic building blocks of digital electronics are logic gates or simply gates. So now this is one example of digital circuit. Here you can see I have taken the LED from analog electronic and connected a battery to this. Now you know LED will emit the light whenever there is a path from battery to the LED, or I can say LED will emit the light if and only if both the switches A and B are closed. Means here this switch A can have two possibilities, either closed or open. Closed means it will allow the current flow, open no current flow. So these kind of variables or this kind of switches are known as Boolean variables. A variable which can have either true value or false value. Only two states are possible. True, false, open, closed, or in terms of binary I can say 1 or 0. So that way these are two switches. So now if A is closed, B is closed, then only light will be there from this LED. This kind of operation is known as an AND operation. A and B. So we say AND operation. In digital circuit, this AND operation is represented by AND gate. And logical expression for this is A dot B or A into B, or I read it as A and B. Now, in comparison to this circuit, let's modify it. Instead of having A and B in series, let's place them in parallel. A is here, B is here. Now in this case, for LED to emit the light, either A or B need to be closed. So this is OR condition. So in digital electronic, OR gate is used for this kind of circuit. So this is a symbol of OR gate, and in OR we write it as plus A or B, right? So truth table. Truth table is a table which gives you the output for all combinations of input. That is, two inputs are there, so we can have 4 configurations. So for each configuration, what will be the output? That table is known as truth table. So here you can see when 1, which represents the closed condition. So A is closed, B is closed, output is 1. 1 means light will be there, otherwise 0 means no light. In this case, in case of OR, when A is open, B is open, both are open, no light, so output is 0. When A either, here you can see B is closed, output is 1. Here A is closed, output is 1. When both are closed, then also output is 1. So here this is OR, truth table of OR gate, this is truth table of AND gate. Now if we see the truth table, or if we analyze the truth table, we can see in case of AND gate, output is 1 for a minimum number of input combinations. That means out of 4 combinations, only 1 combination gives you 1 output. So that's why this is known as mean term or minimum terms. In contrast to that, if you see truth table of OR gate, here you can see output is 1 thrice. So maximum number of input combination gives you one output. So it is known as max term. So output of AND gate is known as mean term. Output of OR gate is known as max term. Now if we combine them or cascade them, we can realize the various expressions. Now this is one example, AND OR operation. So here this is one part, this is another part. So A and B are in series, so A into B. C, D are in series, so C into D, and both are in parallel. This arm and this arm is in parallel. So I can write this as AB plus CD. So this kind of expression where you have multiplication and then summation. So sum of product, SOP, product A into B, one product, C into D, another product, addition of them. So this representation is known as SOP representation, sum of product. And this, in contrast to that, you see this is A, this is B, A plus B, and then multiplication, C plus D. So this is A first plus A plus B into C plus D. So it is known as a POS, product of sums. Now I can equate this network to a logic circuit, which you can see A into B will be represented by AND gate, C into D is again AND gate. Add them together. So here at this point you will get AB, this point you will get CD, and if you add them, this will be AB plus CD. Similarly here, this is A or B, so here I will get A plus D, here I will get C plus D. If I add them, I will get the expression A plus B into C plus D. So these are basic two gates, AND operation and OR operation. Similar to this, we have few more gates. So our next one is NOT gate. NOT gates are nothing but an inverter. Inverter means they'll invert the input. If A is 0, output will be 1, and if A is 1, output is 0. Inversion. So this is your inverter, and these three gates, AND, OR and NOT, are known as basic gates, and these two, NAND gate and NOR gate, are known as universal gate. We'll discuss why they are known as universal gate. Now you can consider this as this is AND gate plus NOT gate will give you NAND gate. So if you see the truth table, it's the complement of this. See, complement of AND table. So this is your NAND. Similarly, complement of OR will give you NOT truth table over here. So these two are very important gate, and they are known as universal gate. Now there are two more gates which are known as a special purpose gate or exclusive gate. Okay, so the next gate is, one is XOR gate, exclusive OR, XOR gate, which is like this. We'll discuss one example of this. This is A, this is B, this is Y, and we write Y as A XOR B. This is a notation for XOR. If I write the expression, this is A bar B or A B bar. Now let's see the truth table here. Truth table, A, B, two inputs, means 4 configuration or 4 combinations, and for each combination you have to find out the output. So this is 0, 1, 1, 0. So this is exclusive OR. Means in this gate you will get a output as 1 when inputs are different. Right? When both the inputs are same, A is 0, B is 0, output is 0, 1, 1 will again give you 0. So this is your exclusive OR. And if you add NOT gate to XOR, you will get XNOR. So next one is XNOR gate, which is like not added to XOR, and you know truth table will be Y is equal to A XNOR B, A XNOR B, and XNOR expression is A bar B bar, and truth table will be same as this. Only thing you need to do over here is Y, just invert it, complement it, 1, 0, 0, 1. So this is the truth table for X NOR. So these are 5 gates: AND, OR, NOT, NAND, NOR, and 2 exclusive or special purpose gate, XOR and XNOR. Thank you.